So hello friends, in the last class we have discussed about all the types of clipper circuits. Today we will start with the clamper circuits. So what are clamper circuits? Clamper circuits are generally those kind of circuits which when exerted with a sine wave or any signal, it clamps a particular section of the signal. Clamps, it means it shifts to the specific signal, a specific section of the signal to the positive half or to the negative half of the output. For example, if we have a signal, a sine wave, and the output is the same sine wave but it is shifted towards the positive section or the positive half, or the same sine wave given to another clamper, it might shift to the negative half. So from clamper circuits there are two types of clamper circuits. One is the positive clamper, another one is the negative clamper circuits. So by definition, in positive clamper circuit, the positive half, so by definition in positive clamper circuit, the entire signal is shifted up to the positive section, and in negative clamper circuit, the entire signal is shifted to the negative half. Now let us discuss the circuit and see the construction and working of positive and negative clampers. Clamper circuit. Now you can see this circuit where a diode is connected with a capacitor in series and diode in parallel, as well as a resistance. Now you can see that when a sinusoidal wave is given, as you can see this is the input signal, in the negative half cycle, the negative terminal is connected, negative terminal here is connected to the negative of the diode, and the positive terminal is connected to the positive of the diode. Therefore, this diode becomes conducting, and when the diode becomes conducting, it is in forward bias condition. Now, in forward bias condition, the V0, we do not have any current passing because the entire current flows in this direction and this capacitor is charged. Now when this capacitor is charged, it stores this sinusoidal wave, the negative half cycle. Now again in next positive half cycle, we have the Vi as well as the voltage from the charged capacitor. Now in the positive half cycle, the capacitor discharges. So in the positive half cycle, the 0 plus Vc, the voltage from the capacitor. So 0 and the increasing voltage, that is the Vi sinusoidal, added with the Vc, that is the voltage from the capacitor, we have a sinusoidal wave in this manner. Now again in the negative half cycle, the capacitor again charges and it decreases from this Vc value to this 0 value, and this process continues in further oscillations also. Now we'll discuss about the negative clamper. So now in negative clamper, only the diode of the negative clamper, here the diode, as compared to the positive clamper, in negative clamper the diode is only reversed. So here what happens, first in the positive half cycle, the positive side of the PN junction is connected to the positive terminal of the voltage source, and the negative is connected to the negative terminal of the voltage source. Therefore it becomes forward biased in nature. Now as it is forward biased, so V0, the current from the voltage from Vi is not transferred to V0. rather the circuit gets completes in this manner and the capacitor C gets charged. Again, in negative half cycle, this is in reverse bias condition and the entire voltage is passed along with the discharge voltage of the capacitor. So, as in the negative half cycle it is passed, so the output of the circuit is in this manner, and this voltage is the VC. VC is the voltage discharged from the capacitor, so it's minus DC because it's in negative half cycle, and the process continues in further oscillations. Now, start with the positive clamper with positive bias condition. So, in positive bias condition, our DC voltage source is being added in series with the diode. Now, here the positive end is connected to the positive of the diode, and here in positive half cycle the positive is also connected to the negative of the diode, but as this is more than it, so it is in forward bias condition, and in forward bias condition this capacitor gets charged, and in reverse bias condition when this VI voltage is greater than the voltage present here, as I said in the clippers in the last lecture. So, but in this condition, in negative bias condition, it gets charged with capacitor, and in positive bias condition, it gets discharged. That is, when the diode is forward biased, the capacitor is charged, and when the diode is reverse biased, this behaves as an open circuit, and along with the capacitor's voltage VC, the VI voltage both come across the V0. Therefore, the voltage we get here is more or less like the same output as we got in the positive clamper. So, positive clamper and positive clamper with positive bias gives same output. Same output, that is, the output, the nature of the output is same, but the values of the peak value and the lower peak value, they are different as compared to positive clamper. That will be explained by taking an example of a problem, because there we have physical values 5 volt, 6 volt, then we have the resistance, then we have the diode saturation current and all. Then we'll calculate the exact value and how the positive clamper is different from positive clamper with positive bias. Now we'll move on to positive clamper with negative bias. So as I said, in negative bias condition, it is all the same as we discussed in the clipper circuit. The construction and operation, the constructions are same, but the operation is also same, and the output is different as we have a capacitor there, which is the clamper circuit. The main advantage of clamper circuit is being decided by the function of a capacitor, because it stores the charge, it stores the current, and it gives the current at another interval, by virtue of which it feels in the output that the certain section of the input is clamped up to another section or erased off and is being resituated in another position. So now we have negative bias condition. So we just alter or reverse the voltage. Now in the first half cycle or the positive half cycle, this is positive and this is negative. So the negative of the diode is connected to the positive, and then negative of the voltage or the negative of the PN junction is connected to the negative of the positive of the diode is connected to the negative of the voltage. Cut. Here, now discussing about the positive clamper with negative bias condition. Here, the positive of the VI or the input voltage is connected to the negative of the diode, and the negative of the voltage source, DC voltage source, is connected to the positive of the diode. Therefore, it becomes reverse biased. But when this increases, the VI increases, this positivity increases, then also it remains in reverse bias condition. So in positive half cycle it remains in the reverse bias condition, so the entire voltage is passed. Now talking about the negative half cycle. In negative half cycle, the negative is connected to the negative of the diode, and from the DC voltage, this is also negative. So both are negative, but this negative is higher in the initial stage. Therefore, it remains in the remains in the reverse bias condition for a certain instant when the V is, as I said, in Clipper circuits. Then when this Vi becomes greater than this V, it again goes to the forward bias condition where it starts conducting. So we have a graph where this voltage, this range of voltage is minus V for this DC voltage source. Now let us move to negative clamper with positive bias. So in negative clamper with positive bias, we have to alter the diode and for positive bias condition, we have to add a plus B, that is the DC source. In negative clamper with positive bias condition, in the first half cycle or the positive half cycle, the positive is connected to the positive of the PN junction and the positive voltage source is connected to the negative of the PN junction. But this positive is greater than this positive. Therefore, it remains in reverse bias condition. But when the Vi increases, as it is a sinusoidal wave, as the Vi increases, this positive becomes greater than this. Then from reverse bias condition, it turns to forward bias condition, allowing this circuit to stay conducting and to charge this voltage Vc. And also in negative bias condition, negative half cycle, it also remains in forward bias condition because the negative is connected to the positive of the diode and positive is connected to the negative of the diode. Therefore, for the entire case, regardless of the first half cycle, section of the first half cycle, the entire circuit remains in forward bias condition. Therefore, the circuit behaves in this manner. And this area, this peak is V. The V which is this voltage source, the DC voltage source. Now you saw the negative clamper with positive bias condition. Now we will move on to negative clamper with negative bias condition. Here only this voltage is reversed. Now let us see how this operates with the sinusoidal input. Now, in the first half cycle, the positive half cycle, the positive is connected to the positive of the diode and negative of the voltage is connected to the negative of the diode. So it is totally conducting in forward bias condition and the capacitor is charged. Now, again when the polarity is changed of the sinusoidal wave, the negative is connected to the positive of the diode and the negative of the voltage source is also connected to the negative of the diode. Now, for this condition it is reverse bias and for this condition it is forward bias. But as this is greater, this voltage, so it totally remains in reverse bias condition. So it's totally conducting. Therefore, the voltage here will be something like this, which is equal, same as to the negative clamper. Here, as I said, positive clamper with positive bias, as they mimic the positive clamper. In the same way, negative clamper with negative bias also mimics the negative clamper, but not in the calculation part. Only nature of the wave is mimicked, but the values of the peak, the values of the drop, the values of the clamp is not unique. That we'll discuss when we'll discuss the problems of positive clamper with positive bias condition and negative clamper with negative bias condition. Now we discuss the positive clamper with negative bias, negative clamper with positive bias, so on and so forth. Now let us move on to rectifiers. So the clamper circuit is finished, the clipper circuit is finished. The next topic to be covered is rectifiers. So what is a rectifier? So rectifier is any circuit which converts a AC signal to any kind of fluctuating, constant or non-constant DC signal. The main function of the rectifier is to remove or to transfer all the negative half cycle voltage output into positive ones or to just erase off. So rectifier can be of three types. It's broadly divided into two types, but the full wave rectifier is of two types. The two types are half wave bridge rectifier, or you could say half wave center capped rectifier. Another is full wave bridge or full wave center capped rectifier. So there are two types of rectifier in terms of function, that is half wave and full wave, and there are also two types of rectifier as per construction, that is a bridge rectifier or a center capped rectifier. So now discuss about the half wave center capped rectifier. So let us draw its diagram. It includes a AC signal connected with a transformer, a core. Along with it, it has a PN junction and a load resistance RL. So this is AC signal, this is transformer, this is load resistance RL, and this is diode D1. So this is the main circuit. So let's see how the operation takes place and how the output is being recovered. So let us assume this is the input signal sine wave. Has two half cycles, the positive and the negative half cycles. So in the positive half cycle, the diode is forward biased and it is conducting. Therefore, the output is in this manner. The entire input is dropped to the output. But in reverse bias condition, this is in reverse bias condition, this does not conduct, therefore this part is kept empty. So if we see oscillated output of a half wave rectifier, so the output is in this manner, where the negative half cycle is being clipped off. So this is an example of a clipper circuit where the negative half cycle is clipped off, only the positive half cycle is present. So this is a transformer based half wave rectifier. Now we will see a full wave rectifier. We have a AC signal and a transformer. So here the transformer is center tapped. That means the connection is done in the center. So here the load resistance is present here, and we have two diodes. In this manner. So this is load resistance RL. So let's see how this circuit operates. We'll draw the input and the output signal below the circuit to make it more clear to understand. So here, this is the input signal, and here let us assume the positive half cycle. In positive half cycle, this is positive and this is negative. So in the positive half cycle, the current flows, this becomes positive and this becomes negative. This is D1, this is diode D1, this is diode D2. D1 is forward biased. So in forward biased condition, it starts conducting, and this is reverse biased for this negative here and the positive here. Therefore it does not conduct, so this remains open. So in positive here, the forward bias condition, the conducts in this plus minus manner. The diode is through the RL we get the output. So here is the output of the first half cycle. Now in the second half cycle, this becomes negative and this becomes positive. So what happens? This is reverse biased and this is forward biased. So this is positive, this is negative. So what happens? This conducts in this manner. Again, this is positive and this is negative. So again, this part of the wave gets transferred here. So the output is here. So in further oscillations, the output of a full wave rectifier, center tapped full wave rectifier, is in this manner. So we finished the two types of center tapped half wave rectifier and center tapped full wave rectifier and transformer based half wave rectifier. Now we will move on to, in practical cases, to make that center tap, it is very difficult. As I showed in the diagram, the arrow mark through the RL is connected to the center of the secondary winding of the transformer, which is really very difficult. So to overcome that, we made in the field of electronics, bridged full wave rectifier is being constructed. So let us see the diagram. This is the transformer and this is the AC signal. Now let us see how the bridge rectifier works. So here is the diode bridge. This is 1, this is 2, this is 3 and this is 4. 4 diodes are connected in this manner, and the load resistance is connected here. So it is diode D1, diode D2, diode D3 and diode D4. So let's see how this circuit operates. It's a very interesting one. Now, assuming a sinusoidal input, we'll check the output. So in the first half cycle, this is positive and this is negative. So the positive is connected here and negative is here. So for this positive, this is for this is forward biased, and for this negative, this is also forward biased. So the current flows in this manner. So here it is positive and here it is negative. So the first half cycle is dropped as it is. Now moving on to the negative half cycle. in negative half cycle, this is negative and this is positive. So for this positive diode D3 is starts conducting in forward bias condition, and for this negative D1 is in forward bias condition. So current flows in this manner. So current flows in here to here, positive to negative, because this is positive. So the drop here, it is clamped up in this manner. So we got the full wave rectifier output. So the output is in this manner. Okay. So this is a bridge rectifier. Let me explain again. In the first half cycle, the diodes conducting are D2 and D4. So the current flows in this manner. In the second half cycle, the diode conducting are D3 and D1. So the current flows in this manner. Okay. So now the concepts of rectifier is finished. So we discussed all the types of rectifier, their construction, and their working. So guys, today in this lecture 5, we discussed about the positive clamper, the negative clamper, and the bias clamper. Where in the bias clamper we discussed about the positive clamper with positive bias and positive clamper with negative bias, as well as negative clamper with positive bias and negative clamper with negative bias. So we did all the construction and working of all these types of clampers, and in the previous lecture, in lecture 4, we discussed all the clipper circuits. So we discussed all the clippers and the clamper circuit. You may get in your exams the different types of clipper and clamper problems. So we discussed some of them in the preceding classes. Again, we discussed about the rectifiers, the half wave rectifier, the full wave rectifier, and the bridge rectifier. In half wave and the full wave we use the transformer, and in the full wave we use the center tap method, and in the bridge rectifier, which is also a kind of a full wave rectifier, where instead of the center tap method we use 4 diodes in a bridge circuit. Now we discuss all these things. In the next lecture we will discuss about the Jenner diode, the avalanche diode, and we'll also move on to the BJT, or the bipolar junction transistor part. So if you find this video informative, hit the like button. If you have any doubts, write to us in the comment section and subscribe to the channel to stay connected with us. Thank you.